Hello, everyone. My name is Tobias Ternström, and I work at Amazon Web Services and dabble in relational databases. I run the product management team for Amazon Aurora and Amazon RDS. And today we're going to look at something pretty interesting, I would say. We're introducing Babelfish for PostgreSQL. And I know Andy talked about this in the keynote. Sean Bice also talked about it in his leadership session on databases. So let's get right into it and see a little bit of a double click onto what this is all about. First of all, we all know that databases are moving to the cloud in an increasing pace. So far, just with our database migration service, we've moved about 350,000 databases to the cloud. That's a pretty astounding number. And there's some big companies moving more and more of their databases to the cloud. And part of this move often involves switching out the database engine. So there's a lot of moves, especially from proprietary commercial databases over to open source databases like MySQL, MariaDB, and PostgreSQL. And the reason for this move away from commercial databases, I think most people are quite familiar with. You have to buy expensive licenses. It's built on proprietary technology, so it's often hard to move the app. The licensing can be complex, and every once in a while you might get a notification from the vendor that you're getting audited, and you have to go through whatever licenses you have to make sure that you're in compliance. So there is quite a few reasons to consider moving to an open source database. So let's take a look a little bit what goes into moving to an open source database. And it sometimes can be not super complicated, but unfortunately a lot of the time there's quite a bit of work involved in moving over. So here we have a typical setup. You have an application that's talking to a SQL server, in this case from Microsoft. And the application obviously uses database drivers that can communicate with SQL Server, and it speaks to SQL Server's TDS endpoint or tabular data stream. That's the network protocol that SQL Server uses. And it uses T-SQL code, which is basically Microsoft's dialect of the SQL language. And now I'd like to get over to this state on the right where I have my app. But it's communicating instead to a PostgreSQL endpoint using PostgreSQL's, in this case, wire protocol or network protocol. And instead of using T-SQL, it's built using PGPL SQL. So what do I have to do in order to move over? And it's really three things I need to do. I need to move over my schema and my data. And there are tools available to do this. From AWS, we offer two specific tools. So I can use the AWS schema conversion tool to migrate the schema over, that is your tables. Often also you can convert other things like some parts of your stored procedures, triggers, and such. And then I use the AWS database migration service to migrate the data over to the database. But then there's one item missing, and that's the actual app. Because the app on the left side here, it uses, again, libraries that connects to the SQL Server endpoint, and it uses T-SQL syntax. So you have to rewrite your T-SQL to PGPL SQL. You have to rewrite your app code to call other libraries than you're using, and you have to switch out those libraries. So that's often where majority of the work goes when you're migrating off of a commercial database. So in terms of the basics, let's just take a very kind of trivial example here just to make a point on what you should expect to run into. So we have an application here connecting again against the TDS endpoint using T-SQL, and we have a table, products table that we've created in here, very simple table, product ID, product name, and a price column. And we're trying to get that over to PostgreSQL. So as we can see here, it uses the money data type. And this is something that Sean alluded to in his session, that the money data type differs between PostgreSQL and SQL Server. So let's take a look at some data now. Let's say we've inserted a product, a clamp, and the price of the clamp is somewhat strange, I guess, in that it has 4 decimals. to the right of the decimal point, but this is to show one of the issues that you can run into. So it's $12 and 81 cents and 82, I guess, hundreds of a cent. So now let's take a look at what it would take to move this trivial table, if you will, an app over to PostgreSQL. So on the left side here, we have a T-SQL query that queries the products table, and it looks for all products that cost less than $30. And it would return, in this case, our one product with the price $12.8182. On the PostgreSQL side, we've created exactly the same table using the same data types. And again, it turns out that PostgreSQL does have a money data type, but the money data type is slightly different from that in SQL Server. So as we can see on the PostgreSQL side, we would return the clamp, but now the price is not $12.8182, it's $12.82. And why is that? Well, it's because the precision in PostgreSQL is 2 decimals rather than 4 in SQL Server. Now you might argue, well, that's fine. I can use the decimal type instead and declare it to be 4 decimals instead. And that's all true, but this is one out of thousands of little things you'll run into, and these little things matter. So while the product being 12.82 cents versus 81.82 may not be a big difference, there are lots and lots of cases where these decimals make a ton of difference. So in order to move the app over correctly, that's what developers spend a lot of their time doing, is making sure that the correctness is there, that the behavior is exactly the same as their existing app. And obviously their existing app may have thousands and thousands or probably millions of lines of code, and maybe some of it is tested, maybe all of it is tested if you're lucky. So are these things in your tests, making sure that these things are exactly right? The app might be old, so it may be a lot of work to make sure that you're actually getting the same behavior. So there are kind of 2 problems, if you will. One is rewriting the code so that it works, and the second one is making sure that the behavior is exactly the same as it used to be on SQL Server. So imagine if you could do something different. And this is exactly what we did together with a few customers, saying, hey, we want to get off SQL Server and we want to get onto PostgreSQL. However, it is just very, very hard to do it. And there's a lot of investment to move an app over. So in this case, we have an Aurora PostgreSQL instance to the right, and we have SQL Server to the left. And the Aurora instance talks PostgreSQL, and as a PostgreSQL endpoint, again, speaks PGPL SQL, and the SQL Server speaks TDS and TSQL. And there is this red line that's between them, and if you will, stopping us to convert and costing us all of this development effort. So what if we could do this? Let's say that in this case, Aurora PostgreSQL could still speak PostgreSQL, PGPL SQL, but it could also speak TDS and TSQL, meaning that one instance is bilingual. It can speak both of these protocols and languages. At the same time, it's still one database underneath the covers. So if you talk to one endpoint, you're altering the state of the same tables as if you use the other endpoint. There's no 2 databases synchronizing or anything like that. It's a single database, but it's bilingual. So I bring back my application here. So in this case, the application can connect directly to the TDS endpoint and speak TDS and TSQL using exactly the same drivers without having to change a line of code. And it could also start speaking PostgreSQL. So if you think about this, if we can do something like this, then the legacy application code can remain written for SQL Server in TSQL and use those drivers. You can continue using the same drivers, like I said, and then the new application code can be written directly to PostgreSQL. So this means you can have the existing code unchanged, if you will, and new development you could start doing in PostgreSQL if you wanted to. So then over time, you're migrating your app, if you will, away from the proprietary protocol and language over to PostgreSQL's open source language and protocol. So that's pretty nifty. So this is what we set out to solve. So we're introducing Babelfish for Aurora PostgreSQL. So this basically enables your SQL Server applications, or your application that were written for SQL Server using SQL Server drivers, using T-SQL, to connect to Aurora PostgreSQL and run with little to no code changes. So you can keep your existing queries. Now, is it a guarantee that you will not have to change anything? No. Obviously, the SQL Server surface area is quite large, so we're focusing on the most commonly used elements. And over time, we'll release updates to this. So over time, there will be less and less code changes you need to do. And a whole lot of apps will have to do zero code changes because we're going after the most commonly used, again, items in the language. So you can keep your existing queries, store procedures, triggers, and you can accelerate your migration a lot. So you can migrate your data and schema over. Your schema now is just run the same DDL, the create table, create procedure, and so on statements directly against the Aurora PostgreSQL TDS endpoint, if you will. And then that's the migration of the schema. And then you can replicate your data over using, for example, DMS. And then your app code, as I said, it stays either unchanged or you have to tweak it a little bit as you move. And then over time, you can choose, well, I want to rewrite everything and I want to get to a completely PostgreSQL environment. So then instead of now having this, I start the project today and then it could go for years. And now it's done. Obviously, as you're working on this project, you have to keep integrating code changes because your product is still presumably moving on the SQL Server side, if you will. So you have to integrate those changes all the time in your conversion project. And once you're done, then you can start using the new database. Whereas in this case, you can just move over. And then at your own pace, if it's important to you, depends a little bit on the project, you can convert. But now all of the app is running on PostgreSQL rather than on SQL Server during the migration. The other thing that we decided to do was very much based on customer feedback was we need to make Babelfish for PostgreSQL an open source project. There are many reasons for this. One of the key ones is that you want to be free to run your PostgreSQL instance where you need it to run. So you may like to run it on Aurora, you may want to run it on EC2, you may want to run it on RDS, you may want to run it on your own server. So that's one of the premises of going to open source is that you are free to run it wherever you need to. The other thing that's important is you're now in this new bimodal world where you run some T-SQL and some PG-SQL at the same time. So you obviously need to run this on your development environment as well. We know that a lot of developers run the full stack, web server, app server, whatever, and database locally on their laptop. And if I use Babelfish for PostgreSQL, then I need to run that on my laptop as well because my app uses both T-SQL and PG-SQL. So we're open sourcing Babelfish for PostgreSQL, which is basically the product that we put on top of Aurora, such that you can both use it in your own environment, if you will, but you can also participate in the project. So we'll be running this completely open on GitHub with public issues, roadmap, all of these things. And you can join the project and contribute in lots of different ways. One obvious way might be the project doesn't support some functionality that's important to your app, and you want to add that functionality. So this means you can now go into the project, you can make the code changes, you can submit a pull request, and we can integrate this, and then you'll have this functionality to run in your own environment and in Aurora PostgreSQL as well. We'll launch this open source project under the Apache 2.0 license, which means it's a very permissive license. You can more or less use it to your heart's desire, so you're not forced to, for example, use it on AWS. We will launch the project in 2021, so you can go online. There's a website out there with some information about the project. The project isn't on GitHub yet, so during 2021 it will be there, and that's when you can start contributing, again, posting issues, submitting pull requests, and so on. So what were the design tenets that went into Babelfish for PostgreSQL? And there's really three things that we learned are absolutely key for this project to really be successful and for it to be as useful as possible to customers. And the first one is related to the slides I showed earlier. It's no compromises on correctness. So what does that mean? Well, it means either you get exactly the same behavior out of your query as you would have gotten on Microsoft SQL Server, or you get an error back, right? You don't get something in between. So take that money data type example. Either you get your 4 decimal precision and rounding the same way as it would have in SQL Server, or we would have errored out on the create table statement saying, sorry, the money data type is not supported yet. Okay, so that's the difference. So whatever actually works, which hopefully is all of your app, you get that functionality, that behavior that you expect. And if there's something that we haven't implemented support for yet, or the community, once we're out on GitHub, hasn't implemented support for yet, then for those things, you get an error message. And then it's very clear, okay, here is some functionality I need to go and switch in my app or contribute to the project and make work. The other one is wire protocol compatibility. So it's critical that you can continue using your same drivers such that you don't have to go and do surgery on your app. Especially with older applications, it can be quite problematic to find the right driver for you to connect into your app. And we know, as you go wandering around your application portfolio, if you will, there'll be a lot of apps that are older. And even some apps are written both using some new framework and maybe programming language, and parts of the app are written in something old. And not having to change out the drivers is absolutely critical for the project not to stall. And the final thing is, there will be things where you want to use PostgreSQL functionality, and you may not want to switch out the driver just because you want to get to some PostgreSQL functionality. And because of this, we wanted it to be possible that if you connect to the T-SQL endpoint, that you can actually call into PostgreSQL and execute PostgreSQL functionality through that endpoint. Same goes for PostgreSQL. You may be connected to the PostgreSQL endpoint as you're rewriting or building new functionality. And there's some functionality that's T-SQL specific that you need. So from that Postgres endpoint, you need to be able to post T-SQL commands and get the SQL Server-like functionality. So those are the three design tenets that went into this project. And that's something that will be important as we go through the open sourcing and working as a community on the project is adhering to these tenets. So in terms of the development model for Babelfish, so let's say I've now migrated my app, it works, I'm running it using Babelfish for PostgreSQL, and now I need to build some new functionality. How should I do it? Well, there's basically 3 ways to do it, and they're fairly obvious, but it's important to be kind of pragmatic on how you do this. One is develop new functionality in T-SQL using SQL Server drivers. So not basically converting, if you will, to PostgreSQL as you're developing. Why would you want to do this? Well, there might be a bunch of effort to retrain developers. There might be, you built your own object relational mapper or some code that generates SQL syntax, and it might just be too much work or work that's not worth it, basically, to change that. And then you can continue then building new functionality using T-SQL and SQL Server drivers. So that's absolutely, a path that's reasonable. Another path is develop new functionality in PostgreSQL using PGPL SQL and using PostgreSQL drivers. So that makes sense if you know that you're moving this project to PostgreSQL and you want it to be kind of native PostgreSQL over time, then you should probably have a principle that says, no new development happens squarely against PostgreSQL. So if you need to change some old code that uses T-SQL and SQL Server drivers, well, then you have to change it to use PostgreSQL. And then the final one is you can go a little bit in between, and this is more, you want to make use of something that you find useful in Postgres that's available there and may not be available in SQL Server. And that's basically to connect using T-SQL or using SQL Server drivers still, but then use this interop layer, if you will, to call into PostgreSQL functionality. And that's nice, I think, especially if your application, if it's hard to switch out drivers in your application for whatever reason, or there's this one place where I need some Postgres functionality, and having that be different is just annoying if nothing else, and adds work to maintain. So then why not just use the interop layer, connect using SQL Server, TDS, and so on, your drivers, and then call into PostgreSQL through the interop layer. There shouldn't really be any performance difference, by the way, between all of these things. We talk about this as a translation layer between SQL Server and PostgreSQL, which sounds like it's some other thing that sits and translates everything. That's not really how we built it. So it is more just like another endpoint on top of PostgreSQL that natively speaks TDS and T-SQL. So performance between the two should be negligible. There shouldn't really be a difference in between them. So what actually works? Well, that's a good question. Does stuff really work? I use stuff. Do you support stuff? Well, the simple answer is maybe, right? As I said, we're focusing on the most commonly used, as best we understand it, the most commonly used parts of T-SQL. But do triggers work? Yeah, triggers work. Can I have stored procedures? Yeah, you can have stored procedures. Can I use cursors? You can use cursors. Can I use both, T-SQL cursors, declare cursor, and client-side cursors when I declare a cursor using the driver? Yeah, you can use both. Nested transactions is not part of PostgreSQL. Can I use nested transactions? Yeah, you can use nested transactions. What about functions? Scalar functions, table-valued functions. Yeah, you can use scalar and table-valued functions. Data types. Do you have money? Well, we kind of declared, if you will, that we do have the money data type. That's pretty obvious. But we also have SQL variant, string types, same kind of collation, if you will, sorting rules for strings, comparison rules for strings as in SQL Server. So we think we have the gambit to make most applications either no code changes or trivial code changes. Of course, there will be some functionality that's not there. And then again, hopefully you can help us add it by joining the project and contributing in GitHub. That'd be awesome. So with that, I'd like to take you on a little tour of Babelfish for PostgreSQL, in this case running on Aurora PostgreSQL. So you get a bit of a sense of what you can do. Hopefully I'll share a little bit more than I did in the demo in Sean's session. But let's take a look.
Okay, so we're here in SQL Server Management Studio, or SSMS, and let's first just see what we're connected to. So I'll run the @ version function, and we can see that we're not connected to SQL Server at all, but to Babelfish for Aurora PostgreSQL, in this case with SQL Server compatibility. Let's try and do something interesting here now, or a little bit interesting, I guess. Let's try and create a table. And this table also uses the money data type that I talked about in the presentation earlier. And we can see we're using references to the Hitchhiker's Guide to the Galaxy with Babelfishes, Pangalactic Gargle Blasters, and whatnot. So I'll insert the products. And now let's see if we can actually connect to this PostgreSQL instance using a PostgreSQL tool. So in this case, I'll connect using dbeaver, which is an open source tool that supports many databases, including PostgreSQL. There we are, and we are connected to the same instance here. So let's try first using select version. And see what we get. And we're running apparently PostgreSQL 11.9. Let's see if this products table is available. So let me select from products, order by price, and let's do something a little bit Postgres-esque here, limit by 5. And we can see that the table is here. Okay, so PostgreSQL really here now is bilingual. It speaks both TDS and T-SQL, and PostgreSQL, Wire Protocol, and PGPL SQL. So next, let's try and add a trigger on the SQL Server side here. So a T-SQL trigger. And we can see here that this trigger is on the products table, executes after update. Set no count on is a SQL Server thing, means don't return rows affected. And then we'll just return the products that were updated. So this inserted table includes all of the products that were affected by the update that, in this case, awoken or fired the trigger. So I'll create the trigger. And let's now update products, set price equals price plus 1, where, product ID, if I can type here, product ID equals 1, for example. I'll execute that, and there we can see that the trigger is executed. We see that it returns the one product I updated, which was the Babelfish, and that's now up to 101 in price, and now it's 102. I executed again. Let's go over to the dbeaver instance, if you will, here, and let's just execute the select statement again, and we can see that the Babelfish is at 102 down here. So we are indeed updating the same database. There are 2 endpoints, a single database. What else can we do here? Let's try something else that's SQL Server-esque, if you will. There we go. So we can use nested transactions, for example. So we have select at tran count in SQL Server, tells you if you're in a nested transaction or not. This is something that's not part of PostgreSQL. So we'll do begin transaction here, and let's do this a couple of times. So here now we're nested, down into 3 transaction layer. And when I roll back in SQL Server, it's the outer transaction that's the actual transaction. So we'll roll back the whole transaction and then select tran count again. But let's run all of these. And we can see we're not in a transaction, and then we can see the nesting running, and then we're outside of a transaction. So that's another SQL Server behavior that's important as you move applications over from SQL Server to PostgreSQL. Okay, let's try and run an actual app here. So I have Visual Studio installed here. Let's open that. And we have a simple Windows application. And you can kind of figure out what it does. We connect to a server. We supply server database, user ID, and password. And when I hit refresh data, it's going to populate this data grid view. And we can see here it uses the system data SQL client SQL connection object to connect. So it's ADO.NET SQL Server, and it's a SQL Server type of connection string. We open the connection, we execute select statement, we ask for a data reader, we use that data reader to populate the data table, and then we specify the data source for the data grid view as the data table. So let's just execute that. And we can see that it works, and we're at the Babelfish at 102 here. So now let's try and see if we can call a stored procedure. So first of all, I have to create my stored procedure. So we have a very simple one prep down here. So create procedure sp get products by price. You give it the max price, and it will return all products that are lower priced than this max price, or lower than or equal to, I guess we should say there. So we create the stored procedure, and then on this side, we have this get products below price button. So we're just going to use that to call into the stored procedure. So let me just copy this that I had here. And now instead of the command text being the select statement, it needs to be the stored procedure name. And then we need to set the command type to be stored procedure. There we go. And then we need to add the parameter also. So parameter add with value, and we're adding the parameter, I think it was max price. And then we'll use decimal parse here to grab the value in the max price text box. And there we go. Okay, that should be enough of a change. Let's run the app again, and now let's say get products below or equal to 100, and there we go. Let's try 10, and it works. So that's pretty nice. We can see now we can use a stored procedure, regular queries. And again, I haven't installed anything special on my client machine. I was using regular SSMS, regular Visual Studio, the same database drivers, nothing else. Okay, let me now switch back to my presentation machine.
Okay, cool. Hopefully that gave you a little bit of a glimpse of what you can do with Babelfish for PostgreSQL. With that, thank you so much for watching. It was awesome to finally get to show this to everyone. We are pretty proud of the project. We have gotten quite a bit of feedback from customers that are super happy that this is out there. And we're so happy that we're open sourcing the project so that we can work together on making Babelfish for PostgreSQL truly awesome. Thanks a lot for watching.